Hello students, in this lecture we will talk about context free grammar. Okay, what is a context free grammar basically? We will discuss about a grammar first of all. Grammar is a way or mechanism for representing a formal language. As I have discussed about the regular languages, I have discussed about the language. What is a language? A language is a set of strings like we have discussed A, B, B patterns, A, B patterns. These are all set of strings. That is a language first of all. Okay. Then these languages are accepted by the machines, like we can say FAs, like for example DFA and FA. Okay, so we have discussed about grammar first of all. Grammar basically is a way through which we can generate a language. Okay, through which we can generate a language, and that language must be accepted by the finite automata, or you can say must be accepted by the DFA and DFA or other machines like push down automata and so on. Further we will discuss Turing machines. Further we will discuss about push down automata also. That is your next unit. Okay, so brief, I am saying that what is a grammar? Grammar will generate that language, and that language must be accepted by the finite automata, or you can say finite machines like DFA and DFA and push down automata. Okay, so then what is a regular grammar then? A regular grammar is basically a grammar which will generate what? A regular language, and that a regular language must be accepted by the automata. Okay, so clear about this? Okay, so regular grammar is basically which can generate a regular language. As I have discussed about the regular languages in the previous classes, what are regular languages? Okay, strings, I am again repeating about that. Strings starting from A, strings ending from A, substring patterns, A union B, intersection, concatenation, clean star, A raised to power, and all these are the examples of regular languages. Okay, got it? So we will come to this point. What are context free grammar then? Context free CFG, you can say CFG is a grammar, is a way of representing, or is a way. So we will talk about CFG. So what is a CFG? CFG is a way, or you can say context free grammar is a way, or is a way to represent or to generate the context free language, CFL, that is CFL. So again I am saying CFG, that is the context free grammar, will generate the context free language. And what is this context free language? Context free language is also known as regular language. Likewise, regular language. Likewise, we have discussed about in regular grammar also. Regular grammar will also will generate regular language. Regular language, I have discussed about that, and that regular language will be accepted by the automata. Likewise, that is the CFG, that is context free grammar, is a way, it is a way to generate that CFL, that is context free language, and that context free language is also known as a regular language, which is accepted by the automata, like automata such that FA, okay, FA like DFA and DFA, okay, or push down automata. Remember one thing, in CFG we can say, in CFG we can say the machine that accepts the language is always the push down automata. Only push down automata is allowed in this context free grammar, okay, but in regular grammar RG you can say, okay, RG will generate the language and that language will be accepted by the DFA and NDFA. Got it? And this is about the regular grammar and context free grammar. So coming to the next point, the way of representing a grammar, representation. What actually I mean to say, what actually the grammar will look like, okay. So grammar representation is like a DFA, we have represented DFA also, NDFA also, that is a 7 tuple system. I think you will remember, you must remember that, okay. So just we are starting with the representation of the grammar. Grammar is just like the 4 tuple system, we can say VN, VT and P and S, okay. 4 tuple system is there in the grammar. For the representation of a grammar we use 4 tuple, okay. This VN, that is the set of non-terminal symbols, and this VT, this VT is set of terminal symbols, you can say, okay. And this P is the production rule, and this production rule will be in the form of this is the non-terminal and this is also the non-terminal. Again I am repeating, this grammar is a 4 tuple system. VN, that is a set of non-terminal symbols, and these non-terminal symbols are capital letters. All capital letters belong to the non-terminal symbols, okay. This VT, this is the set of terminal symbols. All small letters, this belongs to terminal symbols, okay. Then this P, production rule, which I am representing in the form A, that A is a non-terminal which belongs to a non-terminal B, okay. Then S is the starting symbol, as what is the starting symbol in this? A is the starting symbol. So this is the way of representing a grammar, you can say, okay. Now we will start our next topic, you can say, that is the derivations and languages, you can say, or the derivation trees, okay. Derivation trees, we will start. So what are these derivation trees? First of all, derivation trees are how to is the way, first of all, is the way how a word is derived from a context free grammar. As I have discussed, what is a context free grammar? Context free grammar is used to generate the language, and that language must be accepted by the finite automata. okay, or by the push down automata. Okay, so derivation trees just are the just it is the way how a word, how a language, you can say, how a string, you can say, is derived from a context free grammar. Okay, this derivation tree is divided into two parts, that is leftmost derivation tree and rightmost derivation tree. We will discuss about a leftmost derivation tree and the rightmost derivation tree first of all. Okay, so our leftmost derivation, LMD. Okay, leftmost derivation I am going to discuss. What is leftmost derivation tree? Leftmost derivation tree is when the leftmost derivation tree क्या कह सकते हैं, when the leftmost derivation symbol in the derivation is always replaced first by a production rule, then the type of derivation is called leftmost derivation tree. Okay, so I will discuss it by going through an example. We will discuss it through an example. Okay, this is a grammar. This grammar must be given in the exam also. This grammar is also given in this. I am teaching you. This is a grammar. This is the way of representing a grammar. You are watching this. There are the terminal symbols also. Terminal symbols, non-terminal symbols, capital letters also. So this is like a grammar. Okay, this is a grammar first of all. And for this grammar, if we have given a grammar, we just have to generate the language. Okay, and I am giving the language to you. I am giving the string to you, A B B A. This is the language which you have to generate with the help of this grammar. Okay, this is the string or a word or a language, you can say. And this language I am giving you the question that you have to solve this string by this grammar. By if this grammar is given to you and you are asked to generate a language. Okay, you are asked to generate a language A B B B A. So what you will do in that case? In case of LMD, if you have given the grammar, then you have to generate this string. Okay, so we will start with that. We will first take S is equal to A, small a, capital A, and S. This is a grammar first of all. Hai na? This is the way to represent. This is grammar is always given in the exam, so you have to generate the language basically. Okay, so S is A S. Okay, so what you will do to generate this string, to generate this language, what you will put in this A S. Okay, you just have to first of all do one thing. You just have to remember that you just have to put in place of these non-terminals. So because we have to convert this grammar that is in the non-terminals state, we have to convert it into the terminal state. Okay, so first of all, A is small, no problem. Okay, so we have to convert this A, we have to put any one of this in this A because this is a non-terminal. Okay, so A, in place of A, what we will put in that is A belongs to, I think this will be the perfect for that. This will be perfect for that because we have to generate this A B B A. So for that, if we write this A in place of A, ठीक है, in place of A we will write SBA. Okay. So SBA, why SBA?